Example number 4. 4 patients have made appointments to have their blood pressure checked at a clinic. Let X be the number of them who have high blood pressure based on data from the National Health and Examination Survey. The probability distribution of X is given us in the table, and then they've asked us to find in part A, B, C, and D. So before we do this, we need to do check. The problem telling us that the probability distribution of X given in the table below, and we want to check the problem to see it is right or wrong. Remember, we learned before, we need to check the probability one by one to see if they are between 0 and 1. So 0.23, 0.41, 0.27, 0.08, and 0.01, they are between 0 and 1. So the table satisfies the first condition. Now we need to add them up. We add all of these numbers together, and we can see that they are give us the sum equal to 1. So the table satisfies the second condition. So this is the probability distribution table. Now the next step is we need to answer A, B, C, and D. In part A, we want to find the probability of 1. So probability 1 is here, and the probability of 1 is 0.41. So we just simply answer 0.41. In part B, the probability of 2 or 3. You remember the word or in chapter 5 before, we use addition property. Then we have the probability of 2 plus probability of 3. Because of the or, we add, okay? And 2 and 3, they are disjoint. There are nothing in common between 2 and 3. So we do not have to minus the common. Then the probability of 2 is 0.27. The probability of 3 is 0.08. So what do we need to do is we just add the two probabilities together. Then we got the answer is 0.35. Now we have more than 1 in C and at least 1. So before we do that, let's look at this example. If I tell you that I have more than 3 children. So more than 3 children means I may have 4 children or 5. I should not have 4 and 5, but I have to use the word or, okay? 4 or 5, so just one of them, right? Or 6 or 7 and so on. And what if I say I have at least 3 children? So the word at least 3, the word at least means the minimum is 3. So I may have 3 or 4 or 5 or 6 or 7 and so on. So more than and at least, they are talking about more than the numbers 3, but the 3 is included in the at least, but 3 does not include in the more than. So we go back to our example C. We see that more than 1. In this case, more than 1 means probability of 2, because 2 is more than 1, or 3 or 4. We notice that we stop at 4 because we look at the table. So we have 4 is the end. Now we use the additional rule. We add in the probability together. So probability of 2 add probability of 3 plus probability of 4. 0.27 plus 0.08 plus 0.01, then the answer we will get is 0.36. At least 1, it means the probability of 1 or 2 or 3 or 4. And of course, we stop at 4 because 4 is the end. Now we will add the probability of 1, of 2, of 3, of 4 together. So we get 0.41 plus 0.27 plus 0.08 plus 0.01. And the answer we get is 0.77. So in part D, there are another way for us to do. If you remember that the probability of at least 1, so at least 1, it means 1, 2, 3, and 4. We go back from the table, look at the table. So you have 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. The complement of at least 1. That means no one got the high blood pressure. So the probability of none is a complement of the probability of at least 1. So to find the probability of at least 1, we will do 1 subtract the complement. So we do 1 minus 0.23 and we will get 0.77. So we have different way. In part D, we have 2 ways to do.